All right, everyone. Hello. Welcome to my channel. I'm Thomas, and I do educational videos on many different subjects. Today, we're going to continue. I think this is the 28th video that I've done on the reciprocal system of theory, developed by Dewey B. Larson back in the 20th century and updated by Dr. Bruce Perret, Dr. K.V.K. Nehru, Dr. Gopi Krishna, and others in the 21st century. Larson's is a theory of everything. It's really a system of theory. If you have the basic theory, the basic postulates, then you can use them through deductive processes and derive your own theoretical universe from the reciprocal system. Now, Larson developed a good deal of a theoretical universe from his system, and other people have started from that basis and embarked on further development. But I suppose you could go right back to the beginning and develop it right from scratch for yourself. Theoretically, if your logical processes and Larson's logical processes are rational, then you should develop the same universe that Larson developed. Don't know if that would actually happen. But so right now we are in, I believe, the 6th video of going over his book called Beyond Space and Time. This is his final book, was his final book. It came out after he died in 1995. He died in 1990. And we're looking at the 4th chapter here. This book is basically a departure for Larson, and as I have said, some of Larson's followers were objected to his wife putting out this book after he died because they didn't feel like it was up to the level of his other books, because his other books are like cold hard science, and this is getting into the squishy metaphysical, the social sciences, not hard sciences. And so there's a lot of wiggle room here. Larson, in his reciprocal system of theory, starts with his 2 fundamental postulates. The first one, the physical universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. The second fundamental postulate, the physical universe conforms to the relations of ordinary commutative mathematics. Its magnitudes are absolute, and its geometry is Euclidean. And I mentioned that that second postulate is largely in dispute by the people who have gone on with the theory in the 21st century after Larson died, and have kind of imposed this projective geometry instead of the Euclidean geometry. Not really instead of, because the Euclidean geometry is a subset of projective geometry. So they've just kind of made it broader, a broader umbrella that they believe covers more situations. Now, Larson came upon these postulates after 20 or so years of developing his theory inductively by taking measurements and observations and calculations that he was making on his own, and taking specific information and measurements and attempting to apply it to a general situation. So this is his general situation. So this is what he eventually came up with. Now, once you have the general situation, then you can turn it around and use deductive reasoning to develop the theory step by step. And we went over that in the outline of the deductive development of the reciprocal system. I did 15 videos on that earlier. Now, when looking at the metaphysical situation, he has to go back and go do the inductive reasoning again to come up with postulates eventually about the metaphysical universe. Now, the physical universe is really only half the situation in Larson's thing. The universe is composed entirely of motion in Larson's situation. Now, where Einstein is saying that the speed of light is the maximum speed of the universe, Larson is saying that the speed of light is the midpoint of the universe, and that there is an entire universe that's moving faster than the speed of light. And then there's an entire half of the universe that's moving slower than the speed of light. This is the half that we're accustomed to and that we can actually see and observe and measure. This is called the physical universe. He calls it the material sector. And then over here, he's got what you call the cosmic sector. Everything moves faster than the speed of light. And he's trying to probe into this cosmic universe. How do things work in the cosmic universe? What are the relationships? What are the actors? What are the players here in this cosmic universe? Over here we have atoms and we have electrons and we have photons and we have all these things here. Well, not necessarily photons, because photons are kind of on the boundary, but we have these two different sectors, and he's saying that, well, because of the reciprocal relationship between space and time of the first postulate, then I can take the things that I've learned about the material sector and I can extrapolate them to this cosmic sector, except that I just invert or replace space with time. We don't see time, we only see space. So we can't see what's going on over here, but we can extrapolate because we can see what's going on here. And what's going on here is exactly the same thing as what's going on here, except that space and time replace each other. So when you have a relationship that's space over time here, over here you have a relationship that's time over space. Okay, so that's what he's doing in order to come up with these metaphysical postulates. And he comes up with 4 metaphysical postulates here in the 4th chapter that I'm not really going to derive. I've read one of them before, but I'm just going to read all of them. And they're all, we'll discuss it then after I read the 4 metaphysical postulates. The first metaphysical postulate: there are existences in the metaphysical region, the cosmic sector, in the metaphysical region of a more general and less restricted type than the universe of motion that are the basic constituents of the physical universe. So over here we've got basically more wiggle room. These are more general and less restricted. So this is just a specific, the physical universe is a specific instance of motion, a specific application of motion. Over here in the cosmic universe, we have the same, but it's not restricted in the same way that these are restricted, because it's through extrapolation. So we're using analogous or comparable ways of applying this, and we don't really know what we're really getting into. Again, you can see space, but you can't see time. So we kind of know what the space part looks like, but we don't really know what this looks like. But we know that it's the same, but we have to be more general and less restricted. That's the way I understand what he's saying there. Okay, now the second fundamental postulate, second metaphysical postulate, we went over last time a little bit. The metaphysical existences are logical, orderly, and rational. And again, this is another extrapolation, where he says in the material sector, things are logical, orderly, and rational. And in fact, just in order to be a scientist, you pretty much have to stipulate that you are measuring things that are logical, orderly, and rational. They make sense. Otherwise, it would just be randomness. And maybe that's where the chaos theorists come in or whatever. But even the chaos theorists, uh, they're trying to make sense of things that are not making sense. They ultimately have this idea that you know something makes sense. We're trying to figure out what it is. So Larson is just extrapolating that over into the metaphysical sector or the cosmic sector and saying that the metaphysical existences, just like the physical existences, are logical, orderly, and rational. And he also then mentions that they are intelligent, but he doesn't put that in the postulate. Third metaphysical postulate: metaphysical existence conforms to a specific set of laws and principles different in some respects from those of the physical universe. So there are laws and principles in the metaphysical sector, but they're different in some respects from those of the physical universe. In particular, they're different because time and space are inverted, or time is substituted for space and vice versa. And then the fourth metaphysical postulate, which he doesn't derive until a little bit later. Okay, this is the metaphysical existences of which we have evidence are intelligent. Okay, so of which we have evidence. Okay, so that's where he's going here with these four fundamental postulates. And so that is what he's using as his basis for getting started. Okay, this is the result of his inductive reasoning for years on this subject. And now that he has these postulates, he can take the postulates and apply them to the metaphysical universe to deductively construct a metaphysical universe through the same process, step by step, one by one, if this, then that. Okay. Now he's coming to chapter 5, which is called Levels of Existence. We're going to determine what effects on human life will theoretically result from interaction with such metaphysical existences. And we will then verify, because that's part of this inductive process. You have to, when you use inductive reasoning, you have to also verify. So he starts here with what he calls the great chain of being, as it is sometimes called, beginning with the smallest subatomic particle and terminating, he says, with Homo sapiens. Or he says terminating for the present, at least with Homo sapiens. And maybe other people might say that it goes up higher than that, up to planets and stars, logoi. And then he's talking about, for some reason, he kind of, again, assumes that this evolutionary process is how things happen. But he says no evolutionary process in the inanimate world and that evolution doesn't, it doesn't take place when you're dealing with chemicals, when you're dealing with atoms and subatoms. There's no evolution. He calls it aggregation. You have, where he's saying is you need to have life before you need to have a biological process before you have evolution. Like just atoms and molecules do not evolve. They aggregate, meaning that they build up by glomming onto each other and you know going together with each other, and they can get bigger and bigger and bigger that way, but they don't evolve. Um, so uh, he's really he's saying that they can get more through this aggregation process. They get more and more complex, um, and that is really how we get to the biological evolution. So he's looking at this process, um, and saying that at a certain level of aggregation, this biological process takes over. Um, so what he's saying is at a certain level of complexity of inanimate matter, um, it becomes complex enough so that um, it can be exposed to biological evolution. What he's kind of saying is that, where we have this, midpoint between the material and the complex, or the material and the cosmic, and Larson uses this thing. Then this goes back to his all of his writings, scientific writings, and I've mentioned it before. It's called the interregional ratio, and the interregional ratio, is making these delineations. Saying that there's this boundary, the speed of light boundary between the material sector and the cosmic sector. There are also two other boundaries. There's a boundary within each one of these sectors. Over here, he calls it the time region. Over here, he calls it the space region. Because of his first postulate, it's called, a part of it is called the discrete unit postulate. Everything is in units, integers, and so it's a quantized system, meaning that there is one unit of space, like the smallest unit of space. That's one unit. You can't get any smaller than that. And also there's one unit of time, and you can't get any smaller than that. If you get any smaller than one unit of space, you have to invert again, and you move into this realm of time that he calls the time region. So, and the same way, if you get inside one unit of time, then again you invert and you go into what he calls the space region, where everything is space. It's very difficult to kind of work with that, but this is where he comes up with atomic phenomena, through figuring out the basic properties of matter, through dealing with this the time region, especially the time region and the space region. Now, in Larson's system, the time region is I think it's like 4.56 times 10 to the minus 8 centimeters, 10 to the minus 6 centimeters. So it's very small, but it is very large compared to like the atomic size. And then the unit of time is just the amount of time it takes for the speed of light to move one unit of space. And that turns out to be an incredibly small amount of time, 1.52 times 10 to the minus 16 seconds. So within 1 second, you actually have 6.576 quadrillion units of time fit into 1 second. A quadrillion is what you get after you add 3 zeros to a trillion. So it's basically 15 zeros. So there are more units of time in in 1 second than there are, grains of sand or whatever in the universe. Just a huge, a tiny, tiny, tiny number. But the point I'm making is that he's using this thing called the interregional ratio, where when you are comparing two different things in different sectors of the universe, we reside in this space-time, in the time-space universe, in the material sector, but not in the time region. So when we go into the time region to measure something, or we go into the other, we have to use this interregional ratio, meaning that we only see a certain part of what's actually going on. Something gets lost in the translation. It turns out that the vast majority of the information gets lost in the translation. And so we have to use this fraction, which is usually about 156.44, but sometimes it can be as low as 128, and it depends on the other minor calculations that he makes. But in any case, there's a translation that you have to use, and so you have to shrink that level down. It's kind of like if you look at the sun, for example, you only see the surface of the sun. You don't see what's underneath that. And so that is kind of the same concept. We will get into that tomorrow. We'll start try to figure out this interregional ratio, and then we'll go into this difference between aggregation and biological evolution. Okay, see you later.